Hi everyone and welcome to Adminchat. My name's Mike Thomas. Before I launch into today's topic, which is the power of the sequence function in Excel, just a little bit about me. I've worked in IT training for 33 years. I deliver training on a wide variety of applications, but for the past few years I've chosen to focus on Excel and latterly Power BI. Excel includes around 500 worksheet functions, some of which I'm sure you'll know and love. Things like sum and countif and VLOOKUP. Sequence is just another function. It was added to Excel in 2020. However, it's not available in all versions of Excel. That was a commercial decision made by Microsoft. To check whether you have it, go to a blank cell and type equals SEQ. If sequence appears, great. If not, you're out of luck. So, what does it do? It enables you to fill a range of cells, a single column or row, or a multiple column, multiple row range, with sequential numbers such as 1, 2, 3, 4, 5, or non-sequential numbers with an equal interval, such as 5, 10, 15, 20. But why use the sequence function? There are other ways to generate sequential or interval-based numbers, and that was exactly what I said to myself when the function was first announced. I couldn't see a need or a use for it. But that was then. Since then, I've realised just what the sequence function can do, and that's what this video is about, the power of the sequence function. So, without further ado, let's make a start. Before I show you the sequence function, let me show you manual sequencing. Down column A, I want to have the numbers 1 to 20. So if I type a 1 into A1 and a 2 into A2, select both cells, point the mouse at the bottom corner of A2 so the mouse pointer changes to a little black cross, and drag down as many cells as I need, I get the numbers 1 to 20. In column B, I want to have the numbers 5 through to 50, but in increments of 5. So I'll type in 5 and 10, select both of those cells, point at the bottom corner of B2 and drag the mouse down until the little pop-up says 50. In column C, I want the numbers 50 through to minus 30, this time in increments of 10. So I'll type 50 and 40, select both cells, and then drag the mouse down to minus 30. And in column D, I want to generate 10 sequential dates starting from the 7th of September 2023. So drag the mouse down 10 cells. So as I say, you might be wondering why you'd need a function. Well, stick with me and I'll show you. By the way, I'm using the Mac version of Excel, but everything I show you in this video works the same on Windows. So let's start with the basics of the sequence function. I need to generate 20 sequential numbers down column A starting at 1. So I type into A1 equals sequence, or I can type the first couple of characters and select it from the list. The first parameter of the function is the number of rows that I want, and I want 20 rows. Then I put a comma as the parameter separator, although there are some countries in the world that use a semicolon, but I'm guessing you will know whether you use a comma or semicolon. The second parameter is the number of columns, and here I just want one column. The start number is 1, and I want to go up in steps of 1. Close the brackets and press enter. I'm going to delete that formula and I'm going to change it. Going to put again equal sequence, open brackets, and 20. I'm not going to put any of the other parameters in, and the reason for that is because if you don't, it defaults to 1, so it'll default to one column starting at 1 and going up in steps of 1. So equals sequence 20, enter. In column C, I need to generate 10 numbers going down column C, starting at 10 and going up in fives. So again, I'll use the sequence function. Equals sequence, open brackets. I want 10 rows. I want 1 column. I want to start at the number 10 and go up in increments of 5. Close the brackets and enter. And you can see it's starting at 10 and going up in increments of 5. I don't need to tell it the stop value. It will stop in this case after it's generated 10 values. In column E, I need to generate 10 numbers starting at 10 and going backwards in twos. So again, I'll use the sequence function. 10 rows is what I want because I want 10 numbers and each number will be on a separate row. And I want those numbers to be in a single column, so it's 1. I want to start at 10, but because I want to go backwards in twos, I put a -2 as the step. And you can see what we've got there. Start at 10 and 10 items and go down in twos. But it's not just a single column that you can generate. So I'm going to go over to G1, and here I need to generate a 10 by 10 matrix of sequential numbers starting at 1. So again, I'll use the sequence function, and I want 10 rows and 10 columns. And I won't specify the start and the step, so it'll increment in ones and start at 1. Now, when you specify multiple rows and columns, the sequence function, as you can see, works left to right across the columns and then goes down to the next row and works left to right again. I want it the other way around. I want 1 to 10 down column G, 11 to 20 down column H, instead of across row 1, across row 2, and so on. To do this, wrap the transpose function around the sequence function. So I will just edit the formula, click before the equal sign, and type transpose, open brackets, and I'll need a closing bracket at the end. So I've got two functions there nested together. I am transposing a 10 by 10 grid of sequential numbers, and transposing means flip it round. So when I press enter, now I've still got my 10 by 10 grid, but the 1 to 10 is going down a column, 11 to 20 is down a column, and so on. Apart from that last example, the examples so far have focused on a column of numbers. What if you wanted a single row of numbers, 1 to 10? So what I'm going to do there is I'm going to click onto A22 and put the sequence function. I want 1 row and 10 columns. And again, I'll leave start and step out and it'll default to 1. So 1 row, 10 columns. Now I'm sure you've noticed something about all of these functions. When you click into any cell containing a function, a blue border appears around the range containing the numbers. Also, if you look in the formula bar, all the cells, apart from the first cell, appear to be greyed out. This is because the range that contains the values is what's known as a dynamic array, and the sequence function is a dynamic array function. This is a new concept from Microsoft. Until dynamic array functions were added to Excel, which was in 2020, if you had a range of cells like this that contained formulas or functions, each cell contained a function. However, with dynamic array functions, in effect, what you have is one cell, A1 in this case, that contains one function, and the result of the function spills into the neighbouring cells. If you need to edit the function, you have to do it in the first cell. If you need to delete the function, you delete the contents of the first cell and all the spilled functions get deleted. Now, say you type something into A5, So I'm just going to type Mike into A5 and then go back to A1 and put the sequence function in again. And I'll put equal sequence 20 to generate 20 numbers down column A. When I press enter, because there isn't enough room for the results to spill, you get what's called a spill error. But as soon as I delete Mike from A5, the results can spill down as many cells as they need to. Let's move on to another example. Here I have a list of training sessions that I offer, and I want to assign a number to each session starting at 1. And if I add more sessions, I want the numbering to automatically increment without me editing the formula. The way to do this is to convert this list into a table. There are many benefits of storing your list-based data as a table, the main one being that as more data is added to the bottom, the table automatically resizes. To create a table, click in the data and click on Insert Table, or use the keyboard shortcut Ctrl and T. You need to confirm where the data is. Now, because you can't place dynamic array functions inside a table, if you do, you'll get a spill error. I need to set the table to be B1 to B23. So column A needs to remain outside the table. I also need to make sure my table has headers is ticked. Sometimes Excel doesn't recognize the first row as headings, but you do need that box ticked. So if it's not ticked, put a tick in there and click on OK. Now, when you convert a plain range into a table, Excel applies some formatting. If you don't like that formatting, you can go up to the Table tab on the ribbon. On the Windows version of Excel, by the way, it's called Table Design. On the Mac version, you can see it's just called Table. Then click on the little drop-down arrow at the bottom of those styles. On the Windows version, it's a little drop-down arrow at the right-hand side, and select Clear. And that clears the formatting. It's still a table, I've just cleared the formatting. I'm also going to remove the tick from Filter button. So again, it's on the table menu, take the tick out of Filter button, and the drop-down arrow in B1 will disappear. I want to give my table a meaningful name. If you look on the left-hand side of the ribbon, it says Table Name, and it's called it Table 1 because it's the first table I've created in this file. Now, I could leave the name as Table 1, but I prefer to give my tables meaningful names. So I'm going to type training into there because it describes what the data that's in that table is about, and press enter. To get the numbers down column A, I'll click in A2 and type equals sequence, open brackets, and then I'm going to enter another function. It's the rows function. Rows, open brackets, training, where training is the name of the table. So what I'm doing here, and I need another closing bracket. So what I'm doing here is I'm telling it to generate a column of sequential numbers, and the number of items it's going to generate is going to be based on the number of rows in the table called training. So the values that you put in as the sequence function's parameters do not have to be fixed values. They can come from the result of another function, or they can come from another cell in the spreadsheet. But if I press enter, it's generated 22 numbers. I'm then going to delete the row for quick tips, and I just delete that in the usual way. What Excel's done here is it's regenerated the results of the sequence function. So we still have sequential numbers. In this case, of course, you might not want to renumber the items if one gets removed. But if you did, if you'd manually generated the numbers, they wouldn't automatically renumber themselves when a row is deleted. So that's the basics of the sequence function. At this point, you might still be thinking, so what? But there's much more that it can do. In this example, I'm going to use the sequence function to generate a loan repayment schedule. So I'm borrowing $10,000 at an interest rate of 10% per year and paying the loan back over 12 months at $879.16 per month. And there's a formula in B6 to calculate that. The repayment schedule will list the payment numbers and the payment dates and the payment amounts. And each repayment requires a number, payment 1, payment 2, and so on. So what I'm going to do is go to column D, to D3, and I want to generate a list of sequential numbers, one number per row. I want to start at 1, and I want to stop at the number that equates to the number of payments, which, as you can see, is in B5. So I'll put equals sequence, open brackets, and then select B5. Close the brackets and enter. And what that has done, as you can see, is it's generated 12 numbers. If I change the number 12 to 16, it automatically changes it in column D. If I changed it to 10, it changes it to 10. So let's put it back to 12. So the idea is that you can reuse this spreadsheet for different scenarios. Some people might want to take a loan out over 12 months, other people might want to take a loan out over 24 months, and so on. Now, what I want to do now is precede each of those numbers with the words payment number. So I'll double click on the first cell. Remember, when you have a dynamic array, you can only edit the first cell. Click after the equals sign, open double quotes, type payment number space, close double quotes, and an ampersand. So what it's going to do is generate the words payment number and a space, and then the sequential numbers, like that. Column E will show the actual date the money will be taken from my account. The first payment will be 30 days after the agreement date, and then every 30 days. Now, that is flexible. That could be changed for particular customers. We just go and change that value in there. And so we want it to reference that value in the formula. We also want it to reference B10 in the formula, because that is the date of the loan agreement. So let's go back to E3. I need 12 rows of numbers in one column, and the start value is the loan date, which is B10, and in there I'll put equals sequence, open brackets. Now I need 12 dates down column E, one per row, or it could be 24 dates, depends what the value is in B5. So for the number of rows, I want it to pick that up from B5. The data is going to go down column E, so we just want one column. And for the starting value, it's going to be B10 plus B11, because it's going to be the date of the loan agreement plus whatever the repayment interval is, so 30 days in this example. And then finally, the step value is 30, or whatever is in B11. So that's a little bit more of a complex formula. So I'll just go over that one again. We're telling it to generate a number of values. The number of rows is based on what's in B5. It's going to be one column. The start number, in this case it's dates, but the start value is going to be the date that's in B10 plus the number that's in B11, and the increment, the step, is going to be 30 or whatever's in B11. So I'll press enter, and you can see what we get. We get 12 dates 30 days apart. Now, that is because I had already formatted those cells with a date format. If I just select those cells and set the format of those cells to general, we get numbers that are 30 apart. So let me undo that, and that will give me the dates again. Column F will show the total amount paid after each payment. So in other words, in the October payment, it'll be $879.16. The November payment will be 879.16 times 2, and so on and so forth. So to do that, again, I'll use the sequence function. I want it to generate a list of numbers down column F. How many numbers is going to be based on the number of payments. It's going to go down one column. The start value will be what's in B6, and the step will also be what's in B6 because it's incrementing by what's in the monthly payment. So we can see there that after 1 month we've paid off 879, after 2 months we've paid off 1758, which happens to be twice 879, and so on. Now I'm going to change B5 to 24. Press enter, and you'll notice that the total cost of the loan has changed, the monthly repayment has changed, and it's also updated the repayment schedule. I'll change that 24 to 36, and everything has changed again. One thing to point out is that dynamic arrays do not include the formatting. I've set a specific date format on column E, and I've set currency format on column F. If I formatted down to, say, row 50, but the array expands past this, cells below row 50 won't have the same format. So a suggestion is to format more cells than you think you'll need. Not too many, certainly not an entire column, because applying formatting to an entire column can cause the size of the file to grow, which in turn can make using the file quite sluggish. Okay, next example. Imagine you're the PA to the finance director, and you've been asked to convert the data in columns B to D into a visual. Most people would probably create a pie chart or a bar chart because that's all they know. But there are other ways to present numerical data, like a waffle chart, which is what I've done here. I've already created 2 waffle charts, and I need to create a third one to represent Australia and Asia Pac. So what I'm going to do is go to cell AB3 and enter a sequence function in there. I'll put equal sequence 10, 10, 100, -1. So I want a grid of 10 rows, 10 columns. I want to start with 100 and step in increments of -1. Why start at 100 and go down in increments of 1 will become clear in a minute. You can see that what we've got there is a 10 by 10 grid that goes from 100 down to 1. The reason we've got hash signs in the first cell is because the column isn't wide enough to display the number, but we are going to actually hide those numbers in a minute, so I'm not going to change the column widths. What I'm going to do is select all of those cells and apply conditional formatting. So go to conditional formatting and then go to new rule. Now on the Mac, I need to choose classic. For this, you don't need to do that on Windows. But the type of rule I want, whether you're using the Mac or Windows, is only format cells that contain, where the cell value is less than or equal to D6. D6 being the percent of total for Australia and Asia Pac. Because I actually clicked on D6, it automatically makes it absolute with the dollar signs. And in this case, I need to keep the dollar signs because I want every cell that I'm applying conditional formatting to reference D6. What I want to do for any cells that do match that criteria is I want to set a custom format and I want to set the fill color to light blue. And you can see that's exactly what it's done. There's a little bit more I'm going to do. I'm going to select all of those cells and apply all borders to those cells. And then I want to hide the cell contents. So I'm going to select all of those cells with the numbers in. Go to the drop down here on the ribbon. On Windows, it's in the numbers section. It actually says number at the bottom. It doesn't on the Mac. And go to more number formats custom, and into this box here, delete out the word general and type 3 semicolons. 3 semicolons is a special code which means hide the cell contents. And now we have our waffle chart. If I go over to C6 and I change the value from 35 to 50, when I press enter, Australia and Asia Pac now has 28% of the funding, and that is now represented in the chart. The final example I'm going to show you was based on a real life solution that I came up with for someone who wanted a simple planner or calendar, and they also wanted to reuse it each year and take account of leap years. Now you can see that in February we have 28 days. If I change 2023 to 2024, which I know is a leap year, it automatically generates the 29. So how's it working? Well, if I go to B6, I've got a sequence function, and the sequence function is generating a number of values. How many values it's generating is based on what's in B3, and there what's in C3, and there what's in D3, and so on. Now row 3 is hidden, so if I just unhide rows 3 and 4, B3 contains a formula that calculates the number of days in the month that's specified on row 5. So I'm not going to go into the details of how this works because it's got some date functions in there, and this session is really just focusing on the sequence function, but I'm just showing you another example of what can be achieved with the sequence function. And that brings us to the end of the session. I hope you found it useful, and if you have any further questions, please feel free to drop me an email. And don't forget to check out my website and my YouTube channel for more Excel tips and tricks. But until the next time, have an excellent day.